All right, guys. Um, this is a video over number sets, and we've actually already talked about these before. And it's a different way to categorize numbers, but this is review. This is simply just an enrichment activity, something to kind of keep us fresh and hopefully keep us kind of with it a little bit while we're not in the school building. Again, with any questions, email me. If you hear any background noise or anything, or me hollering at my kids, just keep in mind I'm trying to kind of chase after them too. My wife's at work off and on, so she's actually asleep right now. So the first number set we're going to talk about is the natural numbers. And as I told you guys before, the natural numbers are simply just the positive counting numbers. And again, when I say counting numbers, we're going to say whole numbers, like not fractions or decimals or anything like that. But this is the positive counting numbers excluding zero, so meaning does not have zero in it. Best way I tell kids is the natural numbers is pretend you're going out to play a game of hide and seek and you have to count to 20. You're not going to start at zero, you're just going to start at one and carry on. So it's the positive counting numbers excluding zero. There's a very small difference, note, between this set and the set of whole numbers. The next set is indeed the whole numbers. We want to take into consideration it's the positive counting numbers including zero. So exact same as last set, the natural numbers actually fall within the whole numbers. So it's 0, 1, 2, and so on. So you can continue to count forever. We still don't have any negatives, still no fractions, still no decimals. And like it says at the bottom here, this set does include the natural numbers. Just like the previous one, the integers actually include the wholes and the natural numbers. So you'll kind of see this as we continue and progress through here, that most of what we talk about today falls in another category. So the integers is simply just the positive and negative counting numbers. So anything that's still a whole number can be positive or negative. Still no fractions, still no decimals. And like I said before, this includes the natural numbers and the whole numbers. The next set is the rational numbers. So the rational numbers are anything that you can write as a fraction. And now keep in mind, you can write so many things as a fraction. And even sometimes, let's say we have something like 4 over 2. Well, that's a rational number, but if we evaluate what 4 over 2 is, we simply get 2. So 2 is actually a natural number, a whole number, an integer, all of those things. Now, this isn't the case for all rational numbers. Obviously, you can see the examples given here. You have 0.2. That does not fall into any other category. 3 over 5, negative 6 over 5. Those are simply rational numbers. But keep in mind, all those numbers sets that we talked about before fall within this number set. Think about any whole number you've ever had. You can still write it as a fraction by simply putting it over 1. So this set includes all the other sets so far, and we'll see a Venn diagram here in a minute. You guys can pause and recopy that down if that's something you might need. This set is one that's kind of outside of those other ones that we just got done talking about. So the irrational numbers are things that we cannot write as a fraction. And if we can't write it as a fraction, that means that it is a non-terminating, non-repeating decimal. Anything else you would be able to write as a fraction. Some of your more common examples of irrational numbers are things like pi or the square root of 2, or basically anything that's a decimal that doesn't look like it's ever going to stop. Keep in mind, really good examples of irrational numbers are anything that is not a perfect square under the square root symbol. If you're taking the square root of anything that's not a perfect square, it will be an irrational number. It will not terminate. It will not repeat. If it did, we would be able to take a better square root. Last but not least, in this video, we're going to talk about the reals. The reals includes everything that we've just talked about. Now, irrationals and rationals fall separate from each other, but everything that we typically work with at the high school level, minus a couple of advanced classes, fall within the reals. So the reals are simply something that we can put a finite value on in some sort of coordinate plane. As you get into more advanced classes, you'll learn about the imaginary numbers and complex numbers, and those fall outside of, obviously, the reals. Here's a really, really good Venn diagram. I like the way it's put together. I found this online. You can see here the natural numbers start with 1, 2, and 3. Then we work our way out to the whole numbers. Well, the whole numbers is the natural numbers, it just includes 0. Then we work our way out even further to the integers. Again, it is still the whole in the natural numbers, but it starts including the negatives, as you see here. Work our way out a little further, and we have the rational numbers. You see anything that you can write as a fraction or a decimal that stops. And then notice how we have this whole big bubble of rational numbers, and then over here to the side is irrational. These do not fall within any category other than they're also real numbers with these guys over here. So irrational and rational are kind of counterparts to each other. So keep that in mind when you're watching values for checking boxes. So what I have here, this slideshow is on my Google page along with obviously this video. So if you click through this slideshow after you watch the video, there's a link right here to an activity where we basically just categorize, and all you're supposed to do is check all the boxes that apply for the given number or the given value. And you're supposed to tell me whether that number is real, natural, whole, an integer, or all of the above. Now keep in mind, obviously, they all can't be all of the above. For instance, if it's irrational, it cannot possibly be rational, an integer, a whole, or a natural number. By default, it does not fall within that category. Again, you guys, during this time, make sure that you're trying to stay current on some stuff, try to get some activity in, but most importantly, stay healthy, stay safe, and hope to see you guys soon. Good luck.